Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the hotel booking system, the engine that powers platforms like Booking.com, Expedia, Agoda, and Airbnb. We'll cover search availability, booking, payments, calendar synchronization, reviews, and the low-level design trade-offs you need to know for a senior system design interview. Whether you're preparing for a FANG interview or building travel tech at scale, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the hotel booking system, the engine that powers platforms like Booking.com, Expedia, Agoda, and Airbnb. Every day, millions of travelers search for rooms, compare prices, check availability, make reservations, pay securely, and leave reviews, while hotels and hosts manage inventory, pricing, and calendars in real time. We'll walk through the functional requirements, non-functional requirements, system architecture, end-to-end user journey, core models, low-level design, and the trade-offs that come up in a senior system design interview. Whether you are preparing for a FANG interview or building travel tech, this video is for you. Let's get into it. Here is the core problem. A traveler opens a hotel booking app, enters a city and dates, and expects to see accurate prices, real availability, and instant confirmation. But behind the scenes, the system is complex. A room is sold on one channel but still shows as available on another, causing overbooking. A guest starts a payment, the inventory is temporarily held, but the payment fails and the room is stuck in limbo. Hotel owners update pricing or block dates on one dashboard, but the change propagates slowly to search indexes. Fraudulent reviews skew ratings. A high-traffic sale event floods the booking engine, and inventory locks create contention. The business needs a reliable hotel booking system that keeps inventory consistent across channels, handles payments and cancellations gracefully, and gives travelers a fast, trustworthy experience. Let's walk through the functional requirements. First, the system must support search and discovery. Travelers can search by location, dates, number of guests, price range, amenities and ratings, and see sorted, paginated results with photos and reviews. Second, it must provide real-time availability and calendar management, showing which rooms are available for which dates and reflecting updates from hotel owners immediately. Third, it must support booking and reservation workflows, including holding inventory, creating bookings, handling modifications, cancellations and refunds, and enforcing cancellation policies. Fourth, it must integrate a secure payment flow, supporting multiple payment methods, currencies, fraud checks, invoices, and reconciliation with the hotel's accounts. Fifth, it must support notifications and reviews, sending booking confirmations, reminders, and check-in instructions, and letting guests leave verified reviews that are moderated and ranked. These 5 capabilities form the heart of the product. Now the non-functional requirements. The system must be highly available, because travelers book at any time from any time zone, and even a few minutes of downtime can mean lost revenue. It must deliver low-latency search results, ideally under a few hundred milliseconds, to keep users engaged. It must guarantee strong consistency for inventory, because double booking the same room is a catastrophic failure. The system must be secure, handling payment data, personal information, and identity verification in compliance with PCI DSS and regional privacy laws. It must scale horizontally to handle flash sales, holiday rushes, and concurrent bookings across millions of properties. It must be reliable with retries, idempotency, and clear state machines for every booking and payment. And it must be observable, so operators can detect inventory drift, payment failures, and review abuse quickly. Here is the high-level system architecture. On the left, travelers and hotel owners interact through web and mobile clients, which send requests through a CDN and load balancer into an API gateway. The gateway routes traffic to domain services, a search service backed by Elasticsearch or a similar index, a booking service that orchestrates reservations, an inventory service that owns room availability and calendar state, a payment service that handles checkout and reconciliation, a notification service for emails and push alerts, and a review service for ratings and moderation. Data is stored in a relational database like PostgreSQL for bookings and inventory, Redis for caching hot availability and locks, Elasticsearch for search, and object storage for photos and documents. Kafka or another event bus connects the services for asynchronous updates, payment events, and analytics. The architecture is modular so each service can scale independently based on its workload. The key metrics to memorize cold. Search latency, the time from query to result, with a target under 200 milliseconds for the P95. Booking conversion rate, the percentage of searches that turn into confirmed bookings. Overbooking rate, the fraction of bookings that conflict with another booking which should be extremely close to zero. Payment success rate, the percentage of checkout attempts that complete successfully on the first try. Inventory accuracy, the percentage of room availability records that match the real state across all channels. Review fraud rate, the fraction of reviews flagged or removed as suspicious. And finally, system availability, usually expressed as nines, because downtime directly hurts both travelers and hotels. These metrics are what the business actually cares about. Let's trace the end-to-end user journey. A traveler opens the app, searches for a hotel in Paris for 2 guests next weekend, and filters by price, free cancellation, and Wi-Fi. The search returns 20 matching properties with ratings and lowest prices. She selects a boutique hotel, views the room photos, checks the calendar for available dates, and taps reserve. The booking service holds the room for 10 minutes. She enters payment details, and the payment service authorizes the charge. The inventory service decrements availability, and the notification service sends a confirmation email with the booking reference. The next day, she checks in through the app, enjoys the stay, and leaves a 4-star review with photos. Meanwhile, the hotel owner updates pricing for the next season and sees the changes reflected in search within minutes. The core models and algorithms. The inventory model tracks rooms, room types, properties, and availability calendars, usually at the granularity of property, room type, and date. The booking state machine moves a reservation through states like pending, held, confirmed, checked in, completed, canceled, or refunded, with strict rules for each transition. The pricing and calendar model combines base rates, seasonal adjustments, promotions, taxes, and block dates. The payment model records payment intents, attempts, settlements, refunds, and reconciliation status, with idempotency keys to prevent duplicate charges. The review model stores verified guest ratings, text, photos, moderation status, and aggregated property scores. The search index flattens property metadata, availability, pricing, and review scores into documents optimized for fast filtering and ranking. The hardest trade-offs are consistency versus availability during inventory locks and personalization versus privacy in search ranking. Now the low-level design deep dive. The booking flow starts with a search query that hits Elasticsearch for candidate properties, then checks Redis or the inventory service for real-time availability. When a user selects a room, the booking service creates a pending reservation and calls the inventory service to acquire a temporary hold, often using a lease or optimistic lock with a timeout. The user is redirected to the payment service, which creates an idempotent payment intent and processes the transaction. If payment succeeds, the booking moves to confirmed and the inventory hold becomes permanent. If payment fails or the user abandons the session, the hold expires and the room is released. The state is stored in PostgreSQL with transactional integrity, while events are published to Kafka for notifications, analytics, and partner sync. The inventory service uses sharding by property or region and caches hot calendars in Redis to handle high read volume. For reconciliation, a background job matches bookings, payments, and payouts daily. Key takeaways for your interview. First, a hotel booking system is fundamentally a concurrency and consistency problem, so expect deep questions about inventory locking, overbooking prevention, and distributed transactions. Second, always separate read-heavy search from write-heavy booking and payment, and explain why Elasticsearch, Redis, and a relational database each play a role. Third, idempotency is critical for payments and booking creation, because network retries can otherwise cause duplicate charges or reservations. Fourth, design for failure at every step. Hold timeouts, payment retries, cancellation refunds, and inventory release must be handled automatically. Fifth, trust and safety matter for reviews, so mention verification, moderation, and fraud detection. If you can walk through this system with these 5 points, you will signal strong senior-level design thinking. That's it for the hotel booking system. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on the hotel booking system. We covered the full picture, from search and inventory locking, through booking state machines, payment reconciliation, notifications, and reviews. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.